So looking at this, I now understand why some of you says that the Trazaco slab or Trazaco fast floor is one of the most dangerous. You know, this one comes with pure engineering. If you don't know, have an idea how to do it, you don't contact, let's say, masons to come and do it for you. It is for professionals. You see how the load is distributed here, and then here. So when the span is long, basically when the span is long like this, you don't lay the beams parallel to this end, because when you lay the beam parallel to where the span is long, what you are seeing here, instead of like this, you allow the load, which is let's say compressive this in the stress, compressive which is the pushing forces. We have the compressive, which is the pushing forces. We have the pulling forces, which is tensile, and then we have what the sliding one, which is shears. You see what is happening here. So you can see that there is what stress on these beams here. That's why you see tiny cracks over here. I don't know whether you can see it. So up beam. So it comes like this. So there's a lot of pressure over here, which this one cannot carry. And what you are looking at here, this one is not the pre-stressed beam. It's the one that they put iron rod inside. It is not from IPC Trazaco. This one is from Baba Asango Block Factory. And you see how it is done. Come to this place and let's see how everything is like. This is how we distribute the load. And another thing I've noticed is that they have discontinued most of the rings over here, the stirrups. They've discontinued it because they don't know where the beam will be coming. You know, this one is engineering. You have to determine, let's say, this space. Know how it is. If it is, let's say, the span is, let's say, equal, we have a way of introducing a beam in the middle to what? To stand stress in the structures, so that the load can be distributed evenly to the beam. But when you are discontinuing the stirrup, which is to hold the, which is to hold the rebars together, and then what are you doing? So that is what is happening to this one here. You can see what is happening here, and here this is where the lapping joint is. What I'm seeing here is very, very dangerous, because the building is more or less like it is collapsing. Because when you see from here to this place, you can see that this place has also come down, which is more like it is falling. Another thing that I've also noticed is that they use hammer to chisel, let's say, the ends, so that we don't use hammer to chisel it. What we use instead is the cutting machine. You use cutting machine to cut it. You measure the dimension and then you cut it. Look at what is happening here. Cracks in the blocks and all of that. So you can see that there is a lot of stress on this particular building. These are some of the things that this is how some of you guys do it, and then at the end of the day you come to say that, oh, it is wrong. Let me show you something here so you can see where the stress is. When you look at this beam very well, let me start from here. You can see that from here there are no tiny cracks in it. From here all the way up to this place, then the tiny crack starts. This is stress on the beam, because the loads are not distributed properly. You can see it. So the tiny cracks, the loads are not distributed properly. So there is so much stress on the beam right now. This is it. We don't do this in this method of flooring, not at all. If you want to do this, just contact somebody. If it is, let's say, 1,000 CD, the person can come and then lead your people to do it for you. But when you discontinue all the stirrups, because you don't know where the beams will be coming, you can see they discontinue most of the stirrups. So the building is actually on its own. At any point in time, it can collapse. That is the more reason why I now understand why a lot of you says that, oh, okay, this one is dangerous, this one is this. Engage professionals in your work, because you can see that the center here is almost falling. Thank you.